Okay, so get this. What if we could actually cool the planet by like shooting particles up into the atmosphere?
Yeah, so that might sound like something straight out of science fiction, but it's a real area of research.
It is.
It's called stratospheric aerosol injection, or SAI for short.
Wow, SAI. Okay, and get this. There's a new study in Nature that's exploring using solid particles like alumina and calcite for SAI.
That's right. The study's called Injecting Solid Particles into the Stratosphere Could Mitigate Global Warming, but currently entails great uncertainties. And it's a really kind of a new angle on this whole approach.
Yeah, okay. So before we get ahead of ourselves here, how does SAI actually work?
So the idea is basically to sort of mimic what happens naturally after these massive volcanic eruptions.
Oh, okay.
So when a volcano erupts, it spews all these particles up into the atmosphere.
Yeah.
And some of those particles, they actually reflect sunlight back out into space. Right?
Oh, okay.
And that reflection, it actually has like a temporary cooling effect on the planet.
So we're basically trying to create mini volcanoes.
Oh, yeah.
Controlled mini volcanic eruptions.
Controlled, yes.
To combat global warming. That sounds a little risky.
Well, there are definitely risks involved, and that's why this research is so important. We need to really understand, the potential benefits and the drawbacks before we even consider doing anything like this. This study specifically focuses on injecting particles into the stratosphere,
Okay.
which is way up high,
Right,
above
yeah.
the weather that we experience.
Okay, so that makes sense. But why are scientists looking beyond sulfur dioxide? Isn't that usually the go-to for SAI?
Yeah, so sulfur dioxide is definitely the most studied material
Okay.
for SAI, and we have a pretty good understanding of how it, behaves in the atmosphere.
Okay.
But it also has some potential downsides, like contributing to ozone depletion
Oh.
and even warming the stratosphere.
Really?
Yeah.
Oh, that's not good. So are alumina and calcite, are those like the eco-friendly alternative?
Well, we're not totally sure yet, but that's what, they're trying to figure out in this research.
Okay.
Early indications suggest that, they might have fewer of those severe side effects
Oh, okay.
on the ozone layer and less stratospheric warming compared to sulfur dioxide.
Okay, interesting. So let's get down to like the nitty-gritty here. What did this study actually find out about these alternative particles?
Okay, well, to make a fair comparison, the researchers, they adjusted their simulations so that each material, whether it was sulfur dioxide, alumina, or calcite, would result in the same amount of global cooling.
Okay.
They call this normalizing to a radiative forcing of -1 WM2.
Right.
But basically, they made sure each material had the same cooling power.
I gotcha. Okay, so like a level playing field.
Yeah.
In terms of
Exactly.
cooling power. What happens when you compare them head to head?
So this is where things get really interesting. The study, suggests that injecting solid particles like alumina and calcite could actually lead to a pretty significant reduction in some of those negative side effects we were talking about.
Okay.
They found up to 70% less stratospheric warming
Wow.
and up to 40% less diffuse radiation.
Okay, hold on. Back up for a sec. Why is less warming and less diffuse radiation a good thing?
Yeah, that's a great question.
Explain that to me.
So less warming means less disruption to normal atmospheric circulation patterns, right?
Right.
And diffuse radiation is basically it's just scattered sunlight.
Oh, okay.
And less diffuse radiation could mean fewer impacts on plants and, whole ecosystems.
Ah, okay. So less disruption to the atmosphere.
Yeah.
Healthier ecosystems.
Yeah.
I'm starting to see why they're looking into this.
Exactly.
But there's got to be a trade-off somewhere.
Right.
Right.
You're right. One of the main drawbacks is that alumina and calcite would actually require much higher injection rates than sulfur dioxide.
Oh, really? Yeah.
To achieve the same level of cooling.
Why is that?
It's not about their reflective properties.
Ah.
It's how they behave once they're up in the stratosphere. So sulfur dioxide, it undergoes these chemical transformations
Okay.
that actually amplified its cooling power.
Wow.
Alumina and calcite don't have that same advantage.
So it's like sulfur dioxide is a buy one, get one free deal.
Yeah, exactly.
On cooling,
Right.
and the other ones are
Full twice.
full twice.
Yeah.
And I'm guessing that means
Higher costs.
higher cost.
Yeah, cost effectiveness is definitely something to think about.
Right, that makes sense. Okay, so we talked about cost, but what about the impact on the ozone layer? Did they address that in the study?
They did, and this is where things get really fascinating.
Okay.
So the study suggests that based on our current understanding,
Okay.
both alumina and calcite might actually be gentler on the ozone layer than sulfur dioxide.
Okay, that's good.
Yeah.
That's what we want to hear.
Yeah, but there's a major caveat here.
Oh, caveat. What's the caveat?
We still have a lot to learn about how these particles, especially alumina and calcite, are going to,
Right.
behave chemically in the stratosphere.
Yeah.
The study points out that, we're dealing with
Yeah.
complex reactions up there, and there are still a lot of unknowns.
Unknowns?
Yeah.
That doesn't sound good.
It can be a little unnerving that the study highlights that in some less probable,
Okay.
but still possible scenarios. Alumina could actually cause,
Okay.
pretty significant damage to the ozone layer.
Okay, so alumina could be beneficial?
Yeah, or
Right.
it could be harmful. It's a bit of a wild card. We don't have enough information yet to say for sure.
What about calcite? Any potential for ozone drama there?
Calcite's interesting
Okay.
because under certain conditions, it could actually lead to ozone recovery.
Wait a minute. Ozone recovery, so we could actually cool the planet and help the ozone layer.
It's definitely a possibility, but again, we need more research to confirm that.
Wow.
It all comes down to understanding, those chemical reactions that are going to be happening up there.
Right, of course. It sounds like we need a lot more information before we start
I agree.
messing around with
Yeah.
silent, yeah?
The study emphasizes, we need more research,
Yeah.
particularly laboratory studies, to understand exactly how these solid particles are going to be home up there. We need to be able to predict the benefits and the risks, with much greater certainty before we even think about doing this.
Yeah, for sure. This is pretty mind-blowing stuff. So we've learned about these particles that could really be game changers in terms of cooling the planet
Right.
with fewer side effects, but we've also uncovered some pretty big question marks.
Absolutely.
Right?
Yeah.
Especially when it comes to that ozone layer.
The ozone layer, yeah.
We've covered a lot of ground, but there's still more to unpack in this study.
There is.
So when we come back in part 2, we'll delve a little deeper into the ecological impact
Yeah.
of using solid particles for SAI, and we'll also explore how they're modeling those effects on a global scale.
It's complicated.
It is, so don't go anywhere.
We'll be right back.
Welcome back. So before the break, we were talking about those possible benefits of using solid particles for SAI, like less warming and less of that scattered sunlight, diffuse radiation.
Yeah.
But we also learned about those big questions surrounding what it could do to the ozone layer.
Right.
I'm guessing there's other things to consider too, right? Like what about the effects on ecosystems?
Yeah, for sure. You're spot on. The study does mention some ecological considerations,
Okay.
but it acknowledges we need a lot more research to fully understand all those impacts.
Okay, so what do we know so far about how this could affect ecosystems?
Well, one of the key things they highlight is that diffuse radiation, even though, solid particles seem to produce less of it than sulfur dioxide, any increase could still affect plants.
Right.
We're talking about potential changes to photosynthesis, plant growth,
Okay.
and even one of the whole makeup of ecosystems.
Right. Okay, so some plants might actually like the extra diffuse sunlight and others might not.
Exactly.
It's kind of like a mixed bag.
It is, yeah. And that's just one piece of the ecological puzzle, right?
Right.
We also have to think about what happens when these particles, eventually fall back down to Earth.
Yeah, it's not like it just disappears.
Right, exactly. So the study suggests that most of these particles would be deposited through what we call wet deposition,
Wet deposition.
basically rain and snow.
Oh.
And those deposition patterns, they would probably follow, global precipitation patterns.
So places that get a lot of rain would get a lot of these particles.
That's what the models are showing.
Raining down on them.
But of course, things get much more complicated out in the real world.
Right.
Right. So we need more research to really understand how, localized weather patterns and atmospheric, I guess you could say quirks,
Yeah.
might influence where those particles actually end up.
And what about like what those particles do once they're on the ground? Like could they affect the soil and the water?
Yeah.
And ultimately like entire ecosystems?
Yeah, those are all valid concerns. And those definitely need to be studied more. But there is kind of an interesting twist here.
Okay.
So both alumina and calcite, they're naturally occurring materials.
Okay.
In fact, the amount of calcite that's like naturally present in dust and rocks is way more than the amount we'd be injecting for SAI.
Oh, really?
Yeah.
So we're already exposed to these particles anyway.
In a way, yeah. But it's important to remember that the distribution of those particles would be different, right?
Okay.
With SAI, we're intentionally concentrating them in certain parts of the atmosphere.
Right.
And that could lead to, localized deposition patterns that might be different from natural background levels.
So it's not just about the particle itself,
Right.
but where it lands and what that might do to ecosystems.
Exactly. It sounds like a logistical nightmare to figure all this out.
Yeah, it does.
So to try and predict all this, scientists are using these really sophisticated computer models, right?
Okay.
to see how these particles move through the atmosphere,
Okay.
where they'll be deposited, and what the ecological impacts might be.
I can only imagine how complicated those models must be.
Yeah.
How do you even begin to simulate something as dynamic and interconnected as the Earth's atmosphere
Right.
and all the ecosystems?
Yeah, it's a huge challenge. So the model that they used in this study,
Okay.
it's called SOCOL AEERV2.
Okay.
That's a mouthful.
It is.
But it's one of the most advanced models we have for simulating stratospheric aerosol injection. It looks at a whole bunch of factors.
Okay.
Atmospheric chemistry, particle behavior, even radiative forcing.
Radiative forcing. That sounds familiar. Remind me what that is again?
Sure. So radiative forcing is essentially a measure of how much the Earth's energy balance is altered by things like greenhouse gases,
Okay.
or in this case, injecting particles into the atmosphere.
Okay.
It's a key factor in climate change.
So by entusing these particles, we're changing that balance
Right.
to try to cool things down.
Exactly.
But as we've been talking about, those particles also interact with other parts of the atmosphere
Right.
and the Earth's system in
It's complicated.
really complex ways. Yeah.
Yeah, and that's what they're trying to figure out with these models.
It's like solving this giant multi-dimensional puzzle.
Exactly. But, all models are simplifications of reality, right?
Right.
They can give us valuable insights, but they're not,
Perfect.
perfect predictions of what's going to happen.
So we're not just messing with the planet based on a computer simulation.
No.
But it also means there's a chance that something unexpected could happen.
That's always a possibility when we're dealing with complex systems.
Right.
We have to acknowledge that uncertainty.
For sure.
And be really cautious.
It's still amazing that we can even model these effects at all.
Yeah,
It shows how much we've learned about the planet and the climate.
I agree. The advancements in climate science and computing power have been incredible.
Before we wrap up this part, I want to touch on one more thing from the study. It suggests that the effectiveness of SAI might actually depend on, the state of the climate.
Yeah.
What does that mean?
Yeah, that's really interesting. So they ran simulations for both, current climate conditions
Okay.
and projected future conditions based on a high greenhouse gas emissions scenario.
Okay.
And what they found is that in a future with more greenhouse gases, you'd need to inject even more particles
Oh, wow.
to get the same cooling effect.
Why is that? Is it because a hotter planet needs more sunblock to cool down?
It's not quite that simple. It has to do with changes in, atmospheric circulation patterns,
Right.
more greenhouse gases,
Okay.
even the amount of water vapor in the atmosphere. It gets complicated.
So the more we mess up the climate,
Yeah.
the harder it's going to be to control it.
You could put it that way.
Using SAI.
It highlights the fact that FAI is not like a simple fix
Right.
for climate change.
Right.
It's this complex intervention that's interacting with, this already complex system.
Right. Which is constantly changing.
Exactly.
It makes you wonder if we're better off just focusing on reducing greenhouse gas emissions in the first place.
I think that's a really crucial point. SAI might buy us some time, but it's not a substitute for addressing the root cause
Yeah.
of the problem.
We need to tackle climate change
Yeah.
from multiple angles.
Absolutely. We need to think about both mitigating climate change
Yeah,
and adapting to the changes that are already happening.
for sure. So we've covered a lot in this part.
We have.
The ecological impacts of SAI, the challenges of modeling those effects
Right.
on a global scale.
Yeah.
When we come back for the final part of this deep dive, we're going to tackle the elephant in the room, those uncertainties surrounding the ozone layer. We'll also dig into what research still needs to be done before we can even think about using solid particle injection as a climate change mitigation tool. Don't go anywhere. All right, welcome back to the final part of our deep dive. We've been talking about the potential of solid particle injection to fight climate change, but one thing keeps coming up.
Yeah, the ozone layer, right?
Exactly. That seems like the biggest question mark.
It's definitely a huge concern. The ozone layer is super important. It protects us from that harmful UV radiation from the sun.
Yeah, and we already talked about how sulfur dioxide, that's bad for the ozone layer, which is why they're looking into these other materials.
Right.
But it sounds like even with alumina and calcite, there's still so much we don't know.
Yeah, that's the problem. We just don't have enough data on how these particles would interact with ozone in the stratosphere. It could be a whole bunch of different chemical reactions happen up there.
Right, and we need to figure out which ones are most likely, right?
Exactly, and what their overall effect would be.
And that's where those laboratory studies are so important.
Yeah, we need to be able to actually recreate the conditions in the stratosphere so we can study how these particles behave.
And how they interact with ozone. Right.
Exactly.
I can't imagine that's an easy thing to do.
Oh, it's definitely a challenge. But they're using these special chambers that can mimic those extreme conditions,
Okay.
Super low temperatures, low pressure, and even that intense UV radiation.
Wow.
They even have these high-tech instruments to measure the chemical reactions happening.
So it's like a super high-tech atmospheric chemistry lab.
Yeah, pretty much.
Okay, so what are the big questions they're trying to answer?
Well, one thing they're looking at is how the surface of these particles will react with other chemicals in the stratosphere. Like, for example, alumina could react with hydrochloric acid,
Okay.
and that could create chlorine gas.
And chlorine, that's bad for the ozone, right?
Yeah, it's a major ozone-depleting substance.
So even if alumina itself doesn't directly destroy ozone, it could trigger a chain reaction.
Yeah, that's one possibility, but they need to study that more.
Okay, what about calcite? Is there a chain reaction there?
Well, calcite could actually be good for the ozone layer.
Oh, really?
Yeah, it could react with nitric acid and hydrochloric acid, and by removing those acids, it could actually help the ozone layer recover.
Wow, so calcite could be a win-win, cooling the planet and helping the ozone layer.
It's definitely a possibility, but again, we need more research to know for sure.
It's all about balance, right?
Exactly. Finding the right balance between the reactions that deplete ozone and the ones that help it recover.
Right. Okay, so how long will all this research take?
It's hard to say for sure, but it's probably going to be years, maybe even decades.
Okay, so this isn't a quick fix for climate change.
Definitely not.
It's something we really need to think carefully about and do more research on.
Absolutely.
This deep dive has really made me think, we've seen that solid particle injection has potential, but there are also a lot of uncertainties,
Yeah, a lot of uncertainties.
especially about the ozone layer.
That's a big one.
So, what are your final thoughts for our listeners today?
Well, as you continue to learn about climate change and all the different solutions people are talking about, remember that this is a complicated issue. There are no easy answers.
Right.
Keep asking questions, don't believe everything you hear, and make sure your decisions are based on evidence.
That's great advice. This has been a really fascinating look at solid particle injection and its potential role in mitigating climate change. We've learned a lot, but there's still so much more to explore.
Yeah, definitely.
So to our listeners, keep learning, stay curious, and thanks for joining us on this deep dive.